covered desktop. Let's move on to mobile and web. So as a PM that works primarily to bring AI to mobile and web devices, when I tell people that, the first question I get sometimes is, why would you do that? My friends go, Mark, do you know about APIs, data centers, servers? And I say, yes, I know about APIs and data centers, and you can run some really big, incredible models there. But sometimes you need to run your models on device. And the primary reasons are privacy, latency, cost, and offline availability. Let's start with cost. That one's pretty self-explanatory. If you don't need to pay cloud bills, who wants to pay cloud bills? But more meaningfully, it enables different business models. If you think of applications that are free apps or have freemium tiers, or are single payment apps, I know those don't exist that much anymore, but not everyone is using subscriptions. It's really hard as a software developer if you have your application and you're incurring cost every time a user uses that app and they're running LLMs. But if you have an application where the LLM is bundled into the app, there's no variable cost. Privacy. Our devices have our most sensitive data. Some of that data can never leave the device. Other times, when that data does leave the device, it's end-to-end encrypted the entire way. So you as a developer, if you want to run AI against that and use it in your app, that needs to happen on device. Offline availability. Sometimes people travel, they're in a foreign country, like many of us are today. They don't have data. They're on an airplane, they're in a basement with no signal. Your app should still work. And last but not least, latency. Particularly these smaller models are getting really fast on devices, and it can actually be much faster to start getting a response to your user to use an on-device model compared to doing a round trip to the server, particularly if you're working in somewhere where your users don't have great internet connection. Great. We've covered why you might want to use AI on device. Let's jump into two different ways that people use AI on devices today. First, system gen AI. I think everyone's seen a lot of commercials around this lately. On Android, this is Gemini Nano and AI Core. On iOS, this is Apple Intelligence. Most of the platforms are baking LLMs directly into the platforms these days. You see it with Chrome and Chrome built-in AI. This is a little different than built-in or in-app AI. That's where you take a model as an application developer and you bundle it in your application, either as part of the APK or download it over the air after your user installs. Anytime there are two choices, that generally is because there are trade-offs between them, and they're both great. For system models, you generally can get the largest, most capable model. Those are often 3 billion parameters or larger. They're pre-downloaded, which makes them the easiest to use as an application developer, and you get the best quality. But what's the trade-off? Flexibility and customization. When you're using these, take Apple Intelligence, you can use writing features, but you have to use those via UI elements. You can't use an API with an open prompt to build it directly into your application. If you take an in-app model, you have full customization. You ship it, you can do full fine-tuning, you can have it under your own user interface as part of your app. Because these models are smaller, they're often faster, and you also get much wider device reach. And now let's get to Gemma. That's why we're all here today, right? I personally am really excited for the Gemma 3 release because of Gemma 3 1B, which is an amazing in-app model. You might ask, why is that? Well, first, size. When it's quantized, it's only 529 megabytes. Compared to some of these other LLMs, that's really small. If you zip it, it's under 400 megabytes. That makes it very easy to download over the air into an application as an application developer. Because it's smaller, it also enables a much wider variety of devices that are constrained based on RAM. With Gemma 3 1B, you can run it on devices that have 4 gigabytes of RAM or more. That's virtually all devices that are in user pockets and on desks today. Not only that, it's really fast. 2,500 tokens per second prefill is crazy. When you try this in real life, and we have a demo booth, so you should go try it, it feels almost instant. It also has pretty good decode speed at 56 tokens per second. This fits really well for on-device use cases because oftentimes you're processing a lot of context that's in the app and generating short snippets out. All right, we've covered why you would want to run AI on devices. We've covered some different ways you can do it. Let's talk about some use cases and some best practices. Here's a demo that's also out there. that's running Gemma 2, as the demo was built earlier this year, in browser. This is using language to drive the application. So what you're able to do is tell it, and this is an imaginary flight booking software. I'd like to travel to Tokyo from San Francisco. I'd like to go in April. So if you can book it the way out in early April and the way back in late April, show me some flights. Gemma, right in the browser, is able to take that, understand the intent, translate that into the API, and actually hit the API to drive the application to go fetch those results and show it right to you. And remember, this is all happening in browser. This is a new paradigm of application development, where users are able to combine traditional UIs with natural language via voice to drive their applications. I think we're going to start seeing a lot more of this. I know I personally, when I open an app, oftentimes it starts playing music. And I have to go find the setting somewhere buried down in there that might be 3 or 4 pages deep to say, turn off music. I don't want to learn every application. I just want to go to my app and tell it, turn off the music. Or if I'm making a chart in an application, it might be 20 clicks to get that chart how I like it, to get all the lines colored like I would want, all the text in the right places. I shouldn't have to click 20 times. I should just be able to describe to the application what I want to have happen with the graph, and it should just be able to do it for me. This is the type of behavior that we're going to start seeing in applications by integrating LLMs and letting them drive along with the traditional user interface. All right, so we said you can drive the UI. What else can you do with Gemma in your app? Text generation. Seems a little cliche, but in particular, when you take app context and you turn that into generation, it becomes really powerful. We're going to go through a couple examples. There's many, many more. The first is data captioning. There's a whole wave of AI apps or traditional apps with AI that have these AI overviews. If you look under the hood about what they're really doing, they're taking data that's in the application, feeding that into an LLM, and asking it to process that and generate something that the user would understand. Summarization, taking a lot of text that's in the app and condensing it for users in a more readable format. Smart reply. How many apps have in-app messaging? Almost all of them. And when you get a message back, we've had this for a while where you're able to generate a potential response. Historically, these responses have been pre-canned. Yes, no, sounds good. We're seeing more and more smart reply driven by LLMs be able to actually understand the conversation above it and create much more personalized responses that are nuanced to the situation. And last but not least, we also have a demo out that has in-game dialogue where you can see NPCs start to have custom dialogue that's based exactly what's happening in the game. So let's dive a little deeper as an example for data captioning. Pretend you have an app that's a workout app. It records someone's workout as they do it, and at the end, you want to give an overview to the user to say what just happened. I give a prompt to Gemma. You are a fitness coach that provides workout summaries for a client after they record a workout. Generate a short and funny summary from this data. Then I give it the actual JSON. It has some information in there that it was a run, it was 45 minutes, it was a personal record. Let's see how Gemma does. Great effort. That run clocked you up. 45 minutes, happy heart rate, steady pace, and a true personal record. Let's keep going. It's pretty good for a 1B model. That's the same type of overview that we see in apps today that are doing server calls to do that kind of thing. Summarization. No, this isn't general purpose summarization. This is taking content that's in the app and creating useful content to publish. Pretend you're a web app that hosts blogs or articles, and you want to be able to generate social media content for whatever your user is seeing right now. Let's ask Gemma to do it for us. You are a social media consultant. Create a social media post for our target audience to post and share. Include a CTA, keep it short and sweet, less than 50 words. I fed it the first couple of paragraphs of our Gemma 3 on mobile and web blog post, which if you haven't read, we published this morning. It was pretty great too. Let's see what it does. Unlock powerful language models. Gemma 3 lets you bring intelligent offline capabilities into your app, faster and more private. Explore how you can use Gemma 1B for data captioning, NPC dialogues, smart replies, RAG-powered Q&As, and more. And then a bunch of hashtags. I might ask it to do less hashtags, but that's just my posting style. Maybe you guys like hashtags. But this is something that I would post on my social media. All right, those were a couple use cases. Let's talk about best practices. Gemma 1B is a smaller model. And what we see with that is you get much better results if you can customize it on your own data. At the very least, you can do few-shot prompting, which means in your prompt, you can have some examples of the types of inputs and what outputs you expect from them. Even better, fine-tune it. We have a great collab online that shows you how to fine-tune Gemma 3 1B with your own data, convert it to an on-device format, and run it in your app. And last but not least, if you want to use Gemma 3 1B against a lot of data, use RAG, Retrieval Augmented Generation. So we've heard RAG a lot today. I'm sure a lot of you have used it and have studied it. But for those of you who haven't, RAG is a way that you can break up content. Let's say you have a PDF that you want a user to be able to query against. You take the PDF, which is the app content, you chunk it into very small pieces, and you convert those to embeddings, which are vector representations of the intent of that data. You put it in a vector database, and then a user asks a question or a query. That query is used with a retrieval function into the vector database to pull out only the relevant content from that large PDF. Then you take the initial question, the content that you pulled out, and your system prompt, and you put it into Gemma, and it's able to give you a very coherent output. RAG is used widely on servers today. We're really excited that today we've released our Google AI Edge RAG SDK for on-device. So it means on Android, you have an out-of-the-box SDK that has your embedding model, has your vector database, and your retrieval function. And in a few lines of code, you can do this all on your mobile and web devices. We have Android released today. iOS and web are coming later this year. All right. All of you today are going to go away and play with Gemma 3 1B, I hope. When you do your vibe checks, Gemma 3 1B is really awesome. I ask that you do your vibe checks on ways that you would use it in your application, because that's where it really shines. Gemma has many models in this family, and the larger models are wonderful chatbots. But if you do your vibe check for Gemma 1B as a chatbot, you're going to miss a lot of opportunities. All right. Hopefully at this point, you're sold. You understand why you would use AI on devices. You understand how you would. But then your question is, how do I actually put this in my application? Well, we have MediaPipe LM Inference API. This is our really easy API to run Gemma on Android, iOS, and web. So you have full cross-platform support. And it's really fast. We spent the last couple of years optimizing this not only for CPU, but GPU as a first-class citizen, which is rare on mobile. And so you're able to get amazing performance. So what does this actually look like? We say it's easy. Here's a few lines of code, and with just this code, you can integrate Gemma into your Android app. You configure Gemma, you initialize it, and you run it with a prompt. And you may ask, well, that's Android, what about iOS? Well, you configure it, you initialize it, and you run it. This time, it just happens to be in Swift. And so it's the same API translated into native language for Kotlin, Swift, and JavaScript to make it easy for developers. We'll do web last, but I think you guys have gotten the pattern of configure, initialize, and run. We have lots more details in our documentation at this link, or you can Google AI Edge and go to Gen AI. I'm sure you can find it. If I've inspired you to build something cool, or even better, if you're already building something cool by putting AI on the edge, or if you just have any feedback, please reach out on social media. Thank you so much.